Good evening.
Abdullah, you can try now. You can unmute.
Hi, good evening.
Okay, now, thanks.
Hey, Rochek, you need to unmute the students. I just joined a little bit late, but I just did.
Okay, so let's start.
Rochek, before you start, we have two students. Raj is here and
Sidona.
Sidona.
We can connect to EC2 instances and how we can connect over it and perform various operations on it. But purchasing an EC2 option would not as simple as it looks like. We can just go and, or we can say, purchase an EC2 instance, right? So there are multiple
Hey guys,
types
can you hear me?
that you can purchase. So let's talk about the EC2 instance purchasing option. So far,
yeah,
we have been using on-demand EC2 instance. This allows us to
I
run
think
instances on demand.
Rochek, can you hear
Whenever
me?
you need an instance,
sorry.
Abdullah, can you hear me?
this from AWS, and they allow us to run instances on demand. That means they are good.
Muted.
Abdullah, can you hear me?
Yes, I can hear you.
I think Rochek couldn't be able to hear us.
Unmuted.
Hey, so let's start. In the last session, we have seen
Rochek, could you able to hear us?
Where we have seen how we can launch the
Muted.
I think he has some
Unmuted.
issue.
Guys, am I audible?
Yeah, we can hear you, but are you hearing us or not?
I think you couldn't be able to hear us, Rochek. Let me give him a call. 1 second.
Sure.
Hello?
Hey, Rochek, I think you couldn't be able to hear us.
Roger, can you hear me?
Yeah, so you go to the GoToMeeting panel. There is a audio section. You can pick your microphone. You might have selected the wrong microphone.
All right, I'm muting my.
It's again and again going to mute.
Because I muted you because we couldn't be able to hear you.
Oh no. But now I think you can hear me.
We can always hear you. You couldn't be able to hear us. That's what the problem. Could you able to hear us? Okay, let me disconnect from the phone and then I will communicate over the GoToWebinar just to confirm it. Okay, hold on. Okay, Rochek, could you able to hear us now?
Yes, yes, I can hear you now.
Yes. So, okay, so glad that we fixed it. But before we continue, I just want to introduce two more students here. We have Raj, he's a new student, and we have Sidoni. So both are new students. I already shared them the last class videos.
Okay.
So welcome, guys. If you can quickly introduce, give us an introduction. Raj, your background, what do you do?
Yeah, can you hear me?
Yes, Raj.
Yes, we could.
Okay, good. I don't see any controls on the meeting. Yeah, so I'm a web developer. I've been doing it for senior web developer, Java, JavaScript. I used to be a server admin briefly, and I should have studied this a few years ago. Everyone was pushing me to. Really glad you guys are offering this, so looking forward.
Okay, welcome on board, Raj. Raj, have you attended my training before? Your name sounds very familiar.
You know, back in 2000, maybe 10 or 11, I took a SQL.
Yeah. Your name sounds
I've been around with your, I mean,
back.
It's a fantastic thing. Yeah, I think it's the best, you know, because everything's recorded and it's just, it's awesome.
Right.
The support and the information, really good, spot on.
Okay, all right. Raj, welcome back.
Thank you.
All right. Okay, how about you, Sidoni? Would you like to introduce yourself?
Yes, I can. Hi, everyone. My name is Sidoni. I am currently a Scrum Master, and I'm trying to move away from just management to actually doing some work because I see the market is changing. I'm just maybe looking for more job security, I would say. And I started off when I branched into IT, I took the SQL Server class, and I've come back to Mr. Daniel for more.
Yes. Yeah, Sidoni, welcome back.
Thank
All right.
you.
Yeah, so something really, it's a really good add-on to your Scrum Master title. Okay, definitely yes.
Yes. Thank
Okay,
you.
okay, welcome on board, boys. Okay, all right, I'm
Thank
going to
you.
mute myself. You can, Rochak, you can continue.
Sure.
Thank you.
Thank you, everyone. So, in the last class, we have seen about the EC2 instances, how we can launch the instances, how we can connect to the instances, and all these basic details. But till now, we have been using only one type of EC2 instance. One type of means we can purchase the EC2 instances in one or more different model, right? So currently we were using the on-demand instances. So on-demand instances, whenever you need an instance, you go to AWS and say, I need one instance, I need 5 instances, or whatever the number of the instances you require, you demand it from the AWS, and the AWS is going to provision those instances for you. And for those instances, we are going to pay by the second. Okay. So for example, if I'm running my instance only for 1 hour, so I'll pay for 1 hour. If I'm running for more than 1 hour, 2 hours, 4 hours, so accordingly you will be charged. But if you have a different kind of workload, we can optimize our discount and our pricing by specifying it to AWS. So for example, we can reserve these instances, and we have this 1 year and 3 year term, and they are meant for long workload. So as the organization, if you guess your capacity right, that you are running an application and it is going to be a long-term association, so then instead of using the on-demand instances, you can reserve those instances, and with the help of reserved instances, we can get up to 60 to 70% of the discount in comparison to the on-demand instances. For a long time, then a reserved instance is great. And if you want to have a flexible instance type, so for example, if you want to change the instance type over the time, then there is an option of convertible reserved instances for you. So this is just a demo overview slide. We will go in depth about the upcoming slide about each of the purchasing options as well. Now, next we have the saving plan. Saving plan is similarly to the reserved instances, but instead of 7 years are again 1 year and 3 year plan, but instead of reserving the instance here, uh, uh, we commit a specific amount of uses in dollars. So, for example, you commit that in 1 year, I am going to spend $10,000 or $1 million to the EC2 instances. So, again, you are going to get a 60 to 70% discount in comparison to on-demand instances. Now, next is the spot instances. Spot instances are meant for very short workloads. They are very, very cheap. And we are going to get here almost like it is not fixed, but these are like the cheapest type of instances available. And these are type of workload which can terminate anytime, and so you can run any sort of application which can suffer a downtime, because anytime they can lose these instances, and that makes them less reliable. Then we have the dedicated host. Dedicated host allows us to book an entire physical server, and you can control the instances placement. And dedicated instances means no other customer will share your hardware. And then in the last, we have capacity reservation. Capacity reservation allows us to reserve capacity in a specific availability zone for any duration. So now let's go and see these all options.
What is the difference between dedicated host and dedicated instances?
So yeah, let's come to the detailed discussion, then we will discuss. So
Okay.
okay. Now, In case of EC2 on demand, we are going to pay for what we use. So that means if you are using Linux or Windows, we are going to be getting a billing per second. So when you start the instance, you're going to pay for 60 seconds for a minute. But after that, if you run it just for 5 seconds more, so then you will be charged for 65 seconds. So the billing is on a per second basis, but after the first minute. Or for all other operating system, you are going to get a billing per hour. It has the highest cost. Okay, EC2 demand is the costliest option, but there is no long-term commitments. Anytime, if you want, you can discontinue using it, and till the time whatever you have consumed, you are going to get a bill for that. So that means there is definitely it's a recommended for a short-term workloads, and for those type of workloads which you do not want any interruption, not any downtime, where we cannot predict how the application will behave. Okay, so that is the general type of instance. Now we have the reserved instance. Okay, so these number, if you're saying like up to 72%, these are just an approximation. You can have, we can have, right, it's not a fixed number, it's just an approximation, and this number keep changing. So reserved instance in comparison to on-demand instance, you can get a up to 72% of discount. Here we reserve a specific instance attribute, for example, the instance type, the reason, the tenancy, the operating system. So for example, I can go to AWS and I can say I want a T2.micro type of instance in US East 1 region for a Linux based instance. So now why we get the discount? Because this will help us, this will help AWS also to better manage their capacity, because they know now you are going to run this instance for the 1 year or 3 years. We specify a reservation period, either it will be 1 year or 3 years. So there is two options. Like there is no between. There is no in between that you are going to reserve the instance for 6 months or 2 years or 5 years. There is only two options. Either you can reserve your instance for 1 year, or you can reserve your instance for 3 years. And there is 3 payment option also. First is there is no upfront. Second, there is partial upfront, and third is all upfront. Right. So in all upfront, we are going to get the maximum amount of discount. And if we talk about the reserved instances scope, we can reserve the scope into a specific region and to a availability zone as well. That means reserve capacity in a specific availability zone. Right. So if we talk about the payment option, there's 3 options: no upfront, partial upfront, and all upfront. So in all upfront, you pay, and you are going to get the maximum discount in the all upfront, and where you pay whatever your bill is while agreeing to a contract. So let's say if you're going to use some of the instances for 1 year, there will be a billing, and you pay everything in the starting of the agreement only. But in the partial upfront, it is little costly in comparison to all upfront, where you say if your total bill is thousands of dollars, you say I'm paying $500 upfront, but for the 500 I will pay in 12 installment. Third option is no upfront. Here it is like the on-demand pricing, but since you are reserving those instances, it will be cheaper in comparison to the on-demand pricing, where you say I'm not paying anything upfront. Whatever you are offering, I will pay it in the monthly bill only. So there is no upfront payment in that. And EC2 reserved instance is applicable for steady users application, right? So for example, for a database where you can buy or sell your reserved instances at the reserved instance marketplace as well. So then there is a variation of the reserved instance that we call it as a convertible reserved instance. And this is a very specific kind of reserved instance, which will allow us to change the instance type, the instance family, the operating system, the scope, and tenancy. It will be costly in comparison to the reserved instances, because in case of reserved instances, you cannot change the attribute of the instance. So if I reserve the T2.micro type of an instance, Linux instance, in US East 1 region, that will be fixed for the agreement period. But with the convertible reserved instance, if you see that if you booked a T2.micro type of instance, for example, then you, after some time, you say your application is generating more load, or your application is not getting enough load. So you can scale up or scale down the instance family, the instance type, so that you get an optimal solution. Then we have the saving plan. So which is allows us to get a discount based on the long-term storage, which is same as 70% as the reserved instance. But instead, in the reserved instance, we reserved an instance type, for example, T2.nano in US East 1 region for a Linux-based instance. But here, instead of reserving an instance, we are going to commit the users. So you say, I want to spend $100 per hour for the next 1 year or 3 years. So here we are committing the amount. So even if you use it or do not use it, that is the amount that you need to pay. So and any uses beyond the saving plan. So let's say if you commit $100 per hour for your saving plan, but your usage is going beyond the $100, then the billing or over the $100 will be billed at the on-demand pricing. So with the saving plan, we are logged to a specific instance family and region. So for example, we say I want to have the M5 type of instance family in the US East 1, but we are flexible across the instance size. So we can have, like, for example, M5.x large, the M5.2x large, and so on. The OS, we can switch between the Linux and so on. And the tenancy, you can switch between the host, dedicated, and default. So here the difference between the saving plan and the reserved instances is that we are reserving a capacity in terms of the uses. Now comes the spot instance, and this is very interesting type of the instance as well. And from the examination perspective, you are going to get one or two question which are resolved around the spot instance, that they will give you a scenario and they will ask you like how you can basically reduce your cost. So probably you can move your on-demand instances to the spot instances, but we need to understand the concept behind the spot instance and how to get it and for what use cases they will be very useful. Now, spot instance, they have the most aggressive discounts. So you can see you can get a discount of up to 90% compared to the on-demand pricing. So for example, if for an on-demand instance, you are paying $10 that your on-demand instance can come in probably in $1, and then 90% is not an accurate number. You can get up to 90%. But they are the instance that you can lose at any point of time. Okay, because you define a max price, you are willing to pay for your spot instances, and if the spot price goes over it, then you are going to lose it. So they are the most cost efficient instances in AWS, and they are going to be very helpful if we have a workload that can suffer a certain downtime, that can suffer if you have a workload that is resilient to failure. So what type of use cases we can run the spot instance? Well, it could be the batch jobs, data analysis, image processing, any kind of distributed workload or workload that have a flexible start date and end time. Now, on spot instance, they are not suited for the critical job or databases. So in the examination, you will probably get a scenario where either it will be a critical scenario and on which spot instances they are running on the spot instances. So you need to like correct the situation, or there is a non-critical scenario which you can run on the spot instances, which you need to change for the cost optimization. Now, what happens in the spot instances? It is like the bidding. So you say you set your max price. Okay. Now, if that's and there is something called as the spot price. If the spot price goes below your max price, you will allocate an instance. Okay. And you start running your job on these instances. And spot price is dynamic in nature. So it will keep fluctuating. And as your spot price go above your max price, then you will lose your instances. And you will allocate those instances once again the max price, the spot price will come below your max price. So these instances are dynamic in nature. Okay. Any question regarding the spot instance? Yeah.
So I just have to set it up once. So if that it crossed the threshold, it will automatically terminate and it will come back again so that I can process my batch job, like that sort of
Yes,
thing.
exactly. Yes.
So I don't need to manually go and like bid it again, right?
No. You manually do not need to do anything. So we will see this. So there is a concept of spot request. So you need to create a request in which you will define all your parameters. So spot price is you are going to get from the AWS. You will define your max price. So whenever there is, and you will define the number of the instance as well. So in your spot request, you say 10 instance you need to have for your workload. So anytime the price will variate, you will lose and get your instances. You do not need to manually do it.
Sounds good. Thanks.
Okay. Now we have the dedicated host. Okay. So in dedicated host, you get an actual physical server with EC2 instance capacity fully dedicated for our use cases. And we want to have dedicated host in the use case of the compliance requirement, or you need to use your existing server bound software licenses that has billing based on a per socket, per core, per VM software licensing. And this is kind of a use case that you need to access the physical server. Okay, so you can get a dedicated host and get a dedicated host. You again have similar option. Like either you can create a dedicated host on demand, pay per second for the active dedicated host, and again you can reserve your dedicated host as well for 1 year or 3 year, no upfront, and again similar payment method will be available. And this is the most expensive option available because you have complete control over the underlying physical hardware, because you actually reserve a physical server. And so again, a use case is when you have a software that comes with a licensing model. This is bring your own license, or if you have a company that has a strong regulatory compliance need, right? Then we have a dedicated instance. Now, in case of a dedicated instance, these are the instances that run on the hardware that is dedicated to you, which is different from the physical server, but you may share with your hardware with other instances in the same account, and you have no control over the instance placement. So there is a difference between the dedicated instance and dedicated host that we can see it in this table. Okay. So dedicated instance means that you have your own instance on your own hardware, whereas in the dedicated host, you get access to the physical server itself. Okay, and it gives you the visibility into the lower level hardware. So the difference between the dedicated instance and the dedicated host, in case of a dedicated instance, the physical hardware is dedicated to you, but you do not have a control over it. You do not have a visibility over it, how your instances is going to be placed. But in case of a dedicated host, you have a complete visibility. You basically get an access of a physical hardware where you can have a visibility how you are placing your instances on that particular hardware. So that is the difference between the dedicated instance and dedicated host. Any question?
What is the use case? I mean, for the dedicated instance, like where exactly it? I mean,
Okay. So
Did you?
see, yeah. So both of these type of instance, tenancy. So we call it as a dedicated tenancy. For all other instance, it will be a shared tenancy, right? So both of these type of tenancy will be used. So use case will be the same. Okay. So it is like it is for the company that has the strong regulatory or the compliance need. The only difference is, so if you do not want to share your hardware with other AWS customer, then you go with the dedicated instances. But if you want to have the visibility over the instance placement, okay, so then you go with the dedicated host. So you can place your hardware instances in a. So we will see there is a placement group also in AWS. So you can place your instances in a particular topology. In dedicated instance, you do not have that flexibility. So you can only be sure that you are going to be a dedicated hardware for your compliance needed. But if you want a complete visibility how your instance is getting placed, then you will choose your dedicated host.
Sounds good. Thanks.
Yeah. Now in the last, we have the capacity reservation. So we can reserve on-demand instance capacity in a specific availability zone for any duration. Now you see, it's a on-demand instance. So we can reserve on-demand instance in any specific availability zone, and you get access to that capacity whenever you need it. You have no time commitment, so you can reserve capacity or cancel your reservation at any point of time. And there will be no billing discount in this. Okay, the only purpose to reserve capacity. So if you want to get billing discount, you need to combine it with the regional reserve instances or your saving plans. And if you're charged at the on-demand rates. So the benefit of the capacity reservation is, see, what happens sometimes is when you are dealing with hundreds and thousands of the virtual machines, specific to the any AWS availability zone and AWS availability region. So for a time being, you may get a capacity error that you are not going to create more EC2 instance, because in the AWS data center, there is a crunch of capacity at a particular, at that particular moment. So you need to wait till the time AWS is increasing the capacity, or you need to wait till other customer are terminating their instance so the capacity is getting free, and then you can place your instance. So this is not a good scenario when you are a very large company and you want your instances instantaneously. So most of the enterprises, they will use the reserved instances or the dedicated instances or dedicated hosts. But if you're not using any of these and you want, there will be no capacity error that you are going to get, then you can do the capacity reservation for any specific availability zone. Here you are not going to get any discount, but that particular capacity will be reserved for you so that you can use whenever you need it. So you are charged at the on-demand rate, whether you run your instances or not, and it is suitable for the short-term uninterrupted workload that you need to place in any specific availability zone. So we have an analogy here. So which purchasing option is right? So the first one is on demand, and with on demand, like you are coming, you have a resort and you come whenever you like and whatever you like. So you pay the full price and you choose the dates. if you do not liking it, you will check out in 1 day. But if you're liking it, then you probably you will extend your stay. So that is like the on-demand pricing, right? So with on-demand, you're going to pay the maximum price, and then we have the reserved. So well reserved, we will like to plan ahead, and we know we are going to stay for a very long time. In your resort, you have 1, 2, 3 years, and then if you are going to ask the resort that I'm going to stay for 1 year, they probably going to give you a very good discount, because we know that because the resort know that you're going to stay for a longer period of the time. Third is like the saving plan. Saving plan is saying, hey, I know for sure that in your resort, I'm going to spend a specific amount. So let's say I'm coming with $1,000. I am going to spend $1,000 in your resort. So again, then every month for the next 12 months. So in that case, also resort is going to give a good discount for you. Therefore, you may wanna change the room type over the time, different type of rooms you can get, but you have committed that you are going to spend whatever the amount you have committed, right? Now, spot instances are whenever the hotel runs very last minute discount, because now they have some empty rooms and they want to attract people so that the empty rooms will get filled and people bid on getting these empty rooms. So you get a very, very good discount. But in this specific resort, you, like we can kick out. Let's say you got a room for a very cheap price, but tomorrow the room, the price get higher. Someone else is willing to pay the higher price. Then tomorrow you will not get the same room. So similarly with the spot instances, if your max price, if the spot price goes beyond your max price, your instance, you will get kicked out. Of course, like with the resort, the unit is a day, but in case of a EC2 instance, your instances will be kicked out anytime when the spot price is going beyond your maximum price. Now with the dedicated host, it's like you want to book the entire building of your resort, right? So you got your own hardware, your own resort, then the capacity reservation is saying, I am going to book a room for a period with full price, even if you do not stay for it. So if you stay for it, then you are paying for it. If you're not staying in the room, then also you are going to pay for it, right? Now in the slide, the dedicated host and dedicated instance are mentioned. So in case what happens is, for example, dedicated instance, it is like they will, let's say you have a certain section of your resort that will be booked for you. Okay. And you are sure that no other guests are staying in that particular area, that particular area is completely booked by you. In case of a dedicated host, that area is booked by you, but let's say, for example, you have a complete visibility over the physical resources. For example, there is a kitchen. You have a visibility into the kitchen and you can cook your own stuff. So even though you have you have the dedicated instance, the dedicated host is basically the dedicated instance plus the visibility into the physical infrastructure. So these are the purchasing options available for you in any one of the option which is suitable for your application requirement. You can go. So on demand is the costliest one. If you are not going for a dedicated tenancy, otherwise the dedicated host is the most costliest of them all, and the spot instances are the cheapest of them all. So you can see this is just the comparison. So if the price on demand is $0.1, then for the spot instance you are going to get this is 0.38039, and you are going to get up to 60% off. And this is just a reference. So when they say you can get a 90% discount, it's up to. So most of the time the discount will fluctuate from 65 to 75%. And then you have a reserved instance for 1 year. If you're reserving, then $0.62. If you're reserving it for the 3 years, then again you are going to get the 03 around 60% discount. So if you have a reserved convertible instance, then 07 no upfront. So that's a different type. And if you see, if you are reserving the instance for 3 years, it is coming at 037, and it is like in some cases it is cheaper than your spot price as well. The dedicated host, there's on-demand pricing, dedicated host reservation. You can get a 70% of capacity reservation is again the your on-demand pricing. So this is about the purchasing option of your EC2 instance, and the purchasing option is this complicated in EC2 only. Otherwise, for all other services, it is like very straightforward. So, for example, if we use S3, so S3, if I'm storing the 5 GB data, I will be charged for that. If I'm storing 50 GB data, I will be charged for that accordingly. But with the purchasing option, it is little complicated with the EC2 only. So, any question with the purchasing option?
No.
Okay. Now, let's see the spot instances. Okay. So we can get a discount up to 90%. Again, up to 90%. It's not sure that we are going to get the 90%. Most of the time, the discount will fluctuate around 65 to 75% compared to on demand. And so that's a huge saving. So how does that work? So we need to define a maximum spot price. Okay, that we are willing to pay for that spot instance, and then as long as the instance is having a spot price that is less than the max price, we are willing to pay, then we keep that instance. So that max spot price, okay, it is going to change on an hourly basis based on the offer and the capacity. So it will go up, it will go down, and if somehow the current spot price goes over the max price you have defined, then you have two options. Okay, so for these two options, you have a 2-minute grace period. Okay, so that gives you a little bit of a time to do these things. So basically, you will get a notification that now the spot price is gone way beyond your maximum price. So now you have a 2-minute grace period to terminate your instances. So this grace period is like if you want to save a state of your application that is running. If you do not terminate your instances in these 2 minutes, then they will get terminated automatically. So, and the option can be either you're stopping your instance, that means that you shut down everything that you're doing, then you stop your instance. So if Monday the spot price goes below your maximum price, then again you can restart your instance and continue where you left it off. But if you do not need the state on your instance, then you can just choose to terminate your instance and let it go, and that would resume that anytime you would restart your work. So we can start a fresh new EC2 instance as well. Okay, so the two strategy based on the type of the workload you have, but you have a 2 minutes grace period to do so. The other strategy, if you do not want your spot instance to be reclaimed by the AWS, is to use a spot block. See, spot block are no longer available to the new AWS customers since July 2021. And AWS also remove the support from them, but every now and then sometime we get a question in the examination, so that is why it is included in the slide, but otherwise spot block is no longer available. Okay, so with the spot block is when you block a spot instance for a specified time frame, and this can be between 1 to 6 hours, so you get that block without any interruption. Okay, at least on paper, because in the documentation, but it is very rare. In rare situation, the instance may be reclaimed, but overall, when you consider a spot block thing, then the instance will not be reclaimed. That's the whole purpose of the spot block. So when do we use the spot instance? They are for the non-critical workload. Anything which can suffer a downtime and can resume whenever the servers are up. So they are not great for the critical jobs or the databases, but for the batch processing, any sort of the background processes that can suffer the downtime, you can run your spot instances. Now, if you see, you will define your user define the max price, and based on the instance type, based on the data range, and based on the availability zone, there will be different price. So for an M4, we can see this gives us the price for an M4 large instance over 3 period in the spot zone. So as we can see, there are 6 lines. So each line represents an availability zone. So you have 6 availability zones, so 6 prices. As we can see, the spot prices does vary based on the availability zone you are considering over 3 months, and it is varied quite a bit, right? So if you look at this US East 1A, sometime it goes beyond the max price, sometime go above the max price. So your price is going to be changed, and we need to plan according to that price. So any question till now in the spot instance?
Yeah, the spot block. You said like is the discontinued yet, right? But still
Yes.
we are getting interview question, like even though
No, not in the interview question. Sometime
not in
in the
exam.
exam. Sometime, like not is that it is guaranteed we are going to get, but sometime there will be a word like you need to, let's say, continue working on the spot instance for 1 to 6 years. Like for now, they say they can give you a scenario that your application process its logic in 2 to 3 hours. Now, which type of spot instance, which strategy you are going to implement to achieve this with the lowest cost, right? So the option is lowest cost when you see the spot instance, right? But spot instance, you see, they will be terminated anytime, right? But there is something called the spot block that you will see in the option that you can hold your instances for up to 1 to 6 years. So you need to select that option. So this is just for the examination perspective.
Oh.
Okay. Just a second. Now we have something called the spot fleet. Okay. So spot fleet is nothing but it's a combination of some of the spot instances and some of the EC2 on-demand instances. And again, having an on-demand instances are optional. So what happens is, like if you run every instance as, let's say you are running a workload, okay, and in your workload, if you run everything on the spot instances, then these spot instances will get terminated whenever the price is going beyond the maximum defined price that you have defined, right? So, but with the spot fleet, what you can do, you can use a combination of the spot instances plus on-demand instances, right? So that, let's say if your workload is running on 10 servers, for example, then maybe maybe 5 you can use the spot instances or 5 on-demand instances. So anytime if your price is going beyond the maximum spot price, then your application will still run with the 5 instances because that is the on-demand instances. So basically we use the spot fleets to optimize our workloads. So for example, let's say you are running a web server. Now you are running a web server with the 5 on-demand instances, for example. Now, what you can do is instead of 5 on-demand instances, you can say, I need to optimize the cost, and I'm seeing that the usage is also not constant. What I can do is let it be the 3 on-demand instances 2, I will convert it to the on-demand spot instances, so that you will get like a 60% discount on these. So if you are so that if anytime these 2 spot instances are also not present, they got terminated, my application is running with 3 instances, so that is okay. So that is a concept of spot fleet. So spot fleet is going to be a way to define for you to get a set of the spot instances and optionally on-demand instances. That's why it's called a fleet. And the spot fleet will try its best to meet its target capacity with the price constraint that we are going to define. So it will launch from the possible launch pool. It can have a different instance type, different operating system, and availability zone. So in your spot fleet, we can define the multiple launch pools as well. So multiple launch pool, multiple instance type, multiple everything. And then the fleet will choose the best and most appropriate launch pool for us. Right? So when your spot fleet either reaches your budget and or reaches the capacity you wanted, then it will stop launching the instance. So we can define a strategy to allocate the spot instance. So in your spot fleet, the first one is the lowest price. Okay. So, and that is going to be the most popular one from the exam perspective as well, which is the spot fleet will launch the instance from the pool that has the lowest price, and this gives you a lot of cost optimization. And this is a great option if you have a very short workload. And second option is you can also have a diversified way to launch your spot instance, in which case the launch in the spot instance will be distributed across all the pools that you have defined from before, which is great for availability and long workload, because if one of the pool goes, then your instances are running with other pools as well. So then we have the capacity optimized. So you have a pool with the optimal capacity for the number of the instances you want. Then we have the price capacity optimized, which is the first choosing the pool which is the highest capacity available. Then select within that the one which has the lowest price. So which is the best choice for most of the workloads. So the idea is that spot fleets can be complicated, but what we have to remember is that using the spot fleet, we are able to define multiple launch pools, okay, and multiple instance type until you are just entering in the raw power, and then you use the lowest price discount or the lowest price strategy for your spot fleets. Then the spot fleet will automatically request the spot instance with the lowest price for us. So spot fleet gives us an extra saving based on the spot instances because it's smart enough to choose the right instance pool. So basically, with the help of spot fleets, we are just giving the diversifying our workload to allow us to get the maximum amount of saving, and that is the benefit of the spot fleets. So we need to understand the difference between like doing a very simple spot instance request, where you know the exactly the type of the instance you want and the availability zone you want to using a spot fleet, and saying okay, we can. So what we can say is the spot fleet is like the combination in very raw words, spot fleet is the combination of multiple spot requests. Okay, so that which, and when we define the lowest price, so let's say when you define a spot request, you need to select the availability zone and the instance type. Now, instead of selecting one spot request, I create a spot fleet with 3 spot requests in each availability zone, right? And I'm choosing the strategy as the lowest price. Now, in all these 3 availability zone, whichever is having the lowest price, my spot instance will launch accordingly. So it gives you you are getting an advantage of the spot pricing, but in the spot pricing also you're getting the lowest pricing. So that's the benefit of the spot fleets. Okay, so now let's see from the console how we are going to launch an spot instance and other things. So any question regarding the spot leads?
A little complicated, but I think practically.
Yeah, it's a little complicated. Yes, right. So you need to go to EC2. Okay, so here you can see there is you can reserve your instances. So you need to purchase your reserved instances because it's either for 1 year or 3 years. So you need to default the tenancy. You need to define the. So either you can purchase a convertible reserved instance or you can purchase a standard reserved instance. So let's say I'm selecting standard instance type. You need to select. Term would be either 1 year or it will be 3 years. So, and there is a purchasing option. So I'll say all upfront research. So you can see seller is AWS. Seller is AWS, and for 12 months the effective price is this. Upfront price is 56, and hourly rate, since you are paying everything is upfront, there is no hourly rate. But if you, let's say, select no upfront and search, you can see there is no upfront price, but you need to pay an hourly rate for this, right? And you can select the capacity. Let's say I want to purchase 100 instances, right? So, and you need to add to cart. So you can see for 100,000 reserved instances, total due now is 0 because we are not paying anything upfront, but monthly recurring cost is almost 5,000. So that is how you can purchase the reserved instances. If you I'll cancel this. Secondly, we have this capacity reservation as well. Here also you can create a capacity reservation and what type of instance you need to have, what is a platform, and capacity reservation will be stored in your availability zone. Tenancy you can select, then the placement group you can select, and you need to give the when your capacity reservation is ending, you need to give the date, or you can do it manually. Capacity reservation continues until you manually cancel it. So open any instance with the matching attribute and target only instance that target the capacity reservation. So that is how we are going to create the capacity reservation. Then we have the dedicated host. So in this case, AWS will allocate a dedicated host to you. So instance family we select, and the instance type, availability zone. So you can see there is something called the outpost ARN. Now outpost is something by which you need to get an access to that physical hardware. Okay, so that all things we need to give here. And in the last we have this spot instance. So you have the saving plans as well. So flexible, significant discount, all these things. And then you have this spot instance. So unlike the EC2 instance, on-demand instance, if you need to launch an EC2 instance, what you do, you just go and launch your EC2 instance just like that. But with the on-demand instance, with the spot instance, you cannot just launch the instance as it is, right? You need to create a request. Then once the request, it will match something, then you are going to get the instance. So you can see the pricing history for all the 3 availability zone: EU North 1A, EU North 1B, EU North 1C. So here you are getting the on-demand pricing. That is like you can see the comparison. On-demand pricing is 0910, and EU North 1A and C. These are the different, and you can see around 58% saving we are going to get. Pricing history, you can see the savings also. Hey Raj, can you please go on mute? There's a lot of background.
Yeah.
So once you, let's say, you have multiple spot instances, you can see what type of savings you are going to get. Then in the last, you are going to request the spot fleet request, create a spot fleet request. So there is two things. Either you can manually configure all the parameters, like what the image would be, what is the key pair, and all these details, or simply you can give a launch template. Launch template we will see later on, but with the launch template is like it will have all your parameters required to launch an instance. Like, so what type of instance it will be, what type of what type of AMI it is using, all these details. So you can do that. Now here additionally launch parameters. Okay. So here also you can like give all these volumes, monitoring, security groups, all these things, and the target capacity, network, instance type requirement, all these details. And then there is a strategy that you can select. Price capacity optimize, capacity optimize. And here also we select the price. There is that option. So terminate the instance, request are valid, I am fleet role, all these things we are going to select. So estimated hourly price we are seeing, and here you can see it's 88% saving compared to your on-demand pricing. So we need to create a request, and once the request will be in place, you will get your spot instances. So that is how we are going to launch your spot instances here. So this is about the, yeah.
So spot instance and spot fleet is in the same place, right?
Yes, it's in the same place. So we basically, it is like conceptually they are different. So for example, if in your spot fleet you are launching multiple pools, then it's a fleet. But additionally, it's a, in the end, it's a spot instance only. So both of the things you need to request it. So you need to create a spot request for both of the things basically.
Okay. So remember, you just mentioned like it's a combination of spot instances and on-demand instances. So
Right.
where exactly set that configuration?
Okay.
Like
So once you get the spot, see here we are only creating the request. Once you have this what we can say, once you get the allocation, then you need to, so that comes within the AWS config. So there is another service. With that you can create those type of requests. So I right now I'm not 100% sure from where we need to create that, but I will get back to you on this. So I'm not 100% sure on this, but I will take a note on this, and I will show you how to do that.
okay, sounds good. Thanks.
Yeah. Okay. So now with the spot fleets, we have some of the topic that is very specific to this associate level exam. Okay. Now we understand what is a private IP and public IP.
I think we didn't go over, right?
No,
and private.
we still haven't gone. Just the basic understanding I was asking. Okay. So let's say this is your private network. In this, there is two servers. Forget about EC2 for now. So, and there is one user. Let's say on one of the server, web server, on one of the server, web server is running, which is running on port 80, and the user want to access it, access your application. Now what happens is, if your instances are in a private network and they want to communicate to each other, they will be communicating to each other on something called as a private IP. But if someone from the outside want to reach them, they need to reach on their public IP. Okay, so the private IP is routable within this network only. So if this is a network and there are multiple instances, then this private IP is reachable to here only. If I try to reach using the private IP from outside the network, then it is not possible. Private IP can only be reachable within this private network. Okay, while public IP is publicly routable, it's routable over the internet as well. Anyone can able to access it. Now the second thing is, let's assume there is two networks, network 1, network 2. This is one EC2 instance I'm deploying in this network. There is one EC2 instance deploying on this network. So I'll say network 1, network 2. Now, let's say the private IP of this is 192.168.0.1. It may happen the private IP in another instance, in another network could also be the same, because anyone from the outside cannot reach via this private IP. Someone from the inside can only reach it. Someone from the inside can only reach it. So private IP is specific within the network. Outside the network, you cannot actually do it. But let's say if this has a public IP of 10.2.3.4 something, then this public IP you cannot assign not only to this machine, not anyone on the internet. Public IP should be globally unique in nature. So that is the difference between the public IP and the private IP. So like currently we have two sort of IPs, IPv4 and IPv6. So we will be now mostly be using the IPv4, and it is still the most common format used online. IPv6 is comparatively very newer and solves the problem for the Internet of the Things. IPv4 allows 3.7 different addresses in the public space. Okay, so as we discussed, like what is the private and public IP. So web server IP is public IP, internet gateway, while this 192.168.0.1.20/22 is going to remain your private IP, and private IP can be same in different network. So because it is now identified within the network only. So but this web server IP, if you are going to see 79.216.59.75, this is going to be unique across all the networks.
What is /22 means? Like, is it means like?
Okay. Hold this for now. We are going to cover this in the networking section.
Okay.
Okay. Yeah. Okay. So the public IP means the machine can be identified on the internet, because this public IP is going to be routable over the internet, and it must be unique across the whole World Wide Web and can be geolocated easily, because as it says, it is global in nature. While on the other hand, private IP means the machine can only be identified on a private network only. IP must be unique across this private network. Okay, so in this private network, if I create another machine, this machine cannot have a IP that is 168.0.1. You need to assign another IP. Okay, but if I'm creating another machine in another network, then it can have that IP. It is not a problem. So the private IP must be unique across the private network. two different private network can have the same IPs as we are discussing. Machine connected to the World Wide Web will use a NAT and internet gateway. So this line also we will cover more in the networking side. Only a specified range of the IP can be used as the private IP. So do we have the range? Okay. Only a specified ranges of the IP can be used as the private IP. Now what does it means is private IP ranges. So you can see these three are the range. I'll put up this in the chat as well. So these are the range which can assign as a private IP. I cannot just go and say it is not getting copied. Okay, so so I cannot just go and say my private IP is 54.2.3.4. No, it should be within these range. Either it will start from 10.0.0.0 or it will start at 122.16.0.0 or it will start 192.168.0.0. Now, if you say what are these three private ranges, so and this is globally identifiable. You will not find any machine which is having a public IP 10.0.0.0 because it is classified as the private IP. Okay, so these are the fixed. So mostly I use whenever we use so 10.0.0, but generally which is more common is 192.168.0. So this is about the public and private IP range. Now we will discuss more in detail about this IP networking and other things in the networking section. But right now you understand one thing. Whenever you deploy an EC2 instance, okay, so there is something called VPC that is called as the virtual private cloud. It is like a private network in AWS. Now you can have multiple VPCs, but there is a default VPC in every region. After that, there is custom VPCs you can create. So whenever you deploy an EC2 instance, it is going to be placed in any of the VPC. So you can define where your EC2 instance is going to get placed. If you do not define that, like we are doing currently, we are not defining the network and other settings of my virtual machine. So then the virtual machine will go into this default VPC. Okay, it always be within a network. Now every VPC will have its network range. So 192.168.0.2/22 or something like that. So your machine will get an IP. Now this is a private IP range. Your machine will get an IP from this range. Okay, so let's try to do it from the console. So I will go and launch an instance. IP demo. And I'll keep everything as default. Keep where I'll select. Create the key pair. Okay, and you see I'm not by default a network is coming, so I'm not just touching it anything and launch the instance because we do not know anything about the networking as of now, so we are not going in that direction. But by default, an EC2 instance cannot exist without a network. It should be placed within a network. Okay, before that, if I show you the VPC. Okay. So currently, if you see, this is the default VPC, and how we can come to know this is the default. It says, default VPC and says yes. And you see the IP range for this is 172.31.0.0/16 we will cover later on, but let's assume that's 172.31.0.0. So it means that the virtual machine will get an IP something like 172.31.0.1, 0.2 in any of this. So let my EC2 come. If it is going to EC2. You can see there is two address, public IPv4 address and the private IPv4 address. And you can see the private IPv4 address is starting with the network ID. So network ID was 172.31.0.0 and the private IPv4 address is 172.31.33.266. So basically the private IP will originated from the network range that your VPC is having. While public IPv4, you can give anything, and it is randomly selected for you. So, for example, if I go and connect to this, let me enable the port 80 as well on the inbound rule. HTTP from anywhere as of now. Okay. Now sudo yum install HTTPD. Okay. Sudo systemctl start HTTP. Okay, let me see the status. Okay, now HTTPD is running. So if I need to access this web server, what I need to do is I can access this only by the public IPv4 address. See, it works, right? But if I try to open the same within the private IPv4, it will not work. It is not going to work. Let me open the new tab and see. Why so? Because the private IP is routable, accessible, reachable within the network only. So whenever we want to access it from outside the network, we are going to use the public IP. If we want to do the communication from the, so for example, in this case, what we can do is, let's say I deploy a Windows machine here. And from here, if this is your Linux where the web server is running, and this is Windows. Now these both machines are in the same network. Now from here, if I try to access this web server, I can use a private IP. Clear about the private and public IP?
Yes.
Okay. Now, there is something called the elastic IP. Now what happens is when you stop and then start an EC2 instance, it can change its public IP. So if you want to have a fixed public IP for our instance, we need an elastic IP. Now elastic IP is a public B4 IP you own as long as you do not delete it, and we can attach it to one instance at a time. And it is let's do the demo first, and then we will see what is there in the slides. Now let's say you are running a web application, and you are working on the public IP. You distribute this public IP to your team, and teams start using it. Okay, so if I'll give it to you, you can like go and access this web server. Now imagine something happens to this server and you restart it basically. So I'll stop this instance. Okay, it's getting stopped. Okay, must be stopped. Now I'm starting it. It's not installed. Will take the time. Okay, now it is stopped. And now you see here the good thing. Private IP will remain the constant. It will remain the same once it is allocated. But you see public IPv4, it is gone for now. And once you start, if you see, now you see if I try to access this, it is not going to work. And if I connect to this, so you can see the public IP has changed. I'll start the web server again. Right. Now, instead of 51.20.18.95, it will run on this public IP because the public IP has changed. Right? So it works. Now it is working on 13.49.66.216 instead of 51.20.18.95 because it has changed the public IP once you restart your server. So now you distributed this 51 IP to your team members. Now when they are trying to access the web server, it is not reachable. Why? Because the IP has changed. To overcome this scenario, there is a concept of elastic IP. Now in the elastic IP, what we need to do is we go to elastic IP, we allocate elastic IP address, okay, and you allocate it. Now an elastic IP will be created for you. What we need to do is we need to associate the elastic IP address. And I will select my instance. And I'll associate. Now if I refresh, if I go to my EC2 instance, you can see the public IP has been changed now to the elastic IP. And if you open this address, now it is working on this elastic IP. Now the whole purpose of the elastic IP is when you restart your instance, Now, when you restart your instance, the IP is going to be remain the same. You can see the IP is not going anywhere, even though server has not been restarted now. It's running, and the IP is same 13.48.143.171, and it will be gone because we need to start it again. But that's the whole purpose of the elastic IP. So until you're not deleting the association or you're not deleting the elastic IP, it is going to be remain the same. So that is the purpose of the elastic IP. With an elastic IP address, you can mask the failure of an instance or a software by rapidly remapping the address to another instance in your account. We can have only 5 elastic IP in your account. We can ask AWS to increase that as well. But overall, it is not a good practice to use the elastic IP. We will, they reflect the poor architectural design. Instead, we will use a random public IP and register a DNS name to it. Or we will see later in the networking, then we are going to use a load balancer, and we are not going to assign the public IPs to our EC2 instances at all. If until unless very much needed, we do not assign the public IPs to our EC2 instances. So we have seen the hands-on. Okay, clear about this elastic IP, public IP, private IP. Any question? Okay, now we have something called as the placement group. Now, placement group are little more advanced, and we want to use them once we want to have control over how our EC2 instances are going to be placed within the AWS infrastructure. And that can be this strategy can be defined using these placement groups. So we do not get direct interaction with the hardware of AWS, but we can let AWS know how we would like our EC2 instance to be placed compared to one another. So this placement group is useful when you are dealing with multiple EC2 instances. If your application is using a single EC2 instance, then it is not it's not relevant to you. So when you create a placement group, you have 3 strategies available. We have the cluster placement group, in which your instance will be grouped together in a low latency hardware setup within a single availability zone. This is going to give you a high performance but very high risk. Second, we have the spread. Spread means that your instance are going to spread across different hardware, and that is a restriction on this. This means that you can have only 7 EC2 instances per placement group that is spread per availability zone. And when you would use a spread placement group when you have a critical application. Finally, there is one last new kind of a placement group. It is called the partition. It is very similar to the spread, meaning that you want to spread your instance, but here they are spread across many different partitions, and these partitions rely on different set of rack of hardware within an availability zone. So what does that mean is that they are still a spread, but they are not isolated one from another failure. So partitions should be isolated from another partition of failure. So the idea with this is that you can scale through 100 of EC2 instances per group, and that allows you to run applications such as Hadoop, Cassandra, or Kafka. So now let's see all of these placement group in little detail. So for cluster, that means all our EC2 instances are on the same physical rack, which means the same hardware, and it is in the same availability zone. So as we can see, all these instances are on the same hardware. And why would we do that? Basically, we would place them on the same rack because we want to use them as a cluster. We want to use them as a single unit, so that we have a very super low latency and want to have maybe a 10 gigabit, 10 Gbps speed network across them. So that means we have an amazing network, right? But as a drawback of this is if we get somehow that hardware is failing, all your EC2 instance will fail because they belong to a same hardware. So that's a failure. If there is a failure on the hardware, then all the EC2 instance will fail at the same time. So we have increased our risk to have a failure that's gonna be propagated across your entire stack. So when we are going to use this, what's the benefit you are getting with this increased risk? Because we have a great networking connectivity within the placement group. We can have a big data job that will need to complete very fast, or maybe we have a requirement to have an application that needs extremely low latency and high network throughput, and we are willing to take a risk to have this failure. And so this is something we have to realize. Cluster placement group, it is not for every kind of application, but if your application need super high bandwidth and low latency, then the cluster placement group is a nice way of doing this. The second is the spread. Now spread is like the complete opposite of the cluster. In spread, we want to minimize the failure risk. So in this case, when we asked for a spread placement group, all the EC2 instances are going to be located on different hardware. So as we see from the diagram, we have 3 availability zone and we have 6 EC2, right? And each EC2 instance is on a different hardware. So what does this mean is that we get is what we span across multiple availability zone, and there is a reduced risk of simultaneous hardware failure. Why? Because if my hardware 1 fail, I'm pretty sure that hardware 2, 3, 4, 6 will not fail. So we have separated the risk of the 2 instances in US East 1A to fail at the same time. So that is a benefit from it. The drawback from this is we are limited to 7 instances per availability zone per placement group. So if your application is running with, let's say, you have 30, 40 instances and you want to span is through the spread group, then maximum you can run 21 instances per placement group. 7, if it is a 6 availability zone, then 42 instances. So that's a drawback to this. So there is a limit to how big your placement group can be. And so you need to have an application that's gonna be of good size, but not very big. So that use case would be an application that need to maximize the high availability and reduce the risk. And in general, for the critical application where your instance failure must be isolated from one another. So remember here we have a limitation of 7 instances per availability zone per instance group. So that is the drawback for the spread. Now third is the partition. We have instances in the partition placement group. We have instances spread across partition in multiple availability zone. Now we can have up to 7 partition per availability zone. So in this example, we have partition 1 and partition 2 in US East 1A and partition 3 in US East 1B. And on each partition, we can have as many EC2 instances. So in the first partition, we have 4, second partition, we have 4, and the third one also we have 4. So why do we want to have a user placement, partition placement group? Because each partition represents a rack in AWS. So by having many partitions, you are making sure that your instances are distributed across many hardware racks. So therefore, they are safe from a rack failure from one another. We can have up to 7 partition per availability zone, and then these partition can span across multiple availability zone in the same region. So this way we can get up to hundreds of EC2 instances with this setup, and that's the difference between the spread and the partition placement group. So the use case of this is like you can run HBase, Cassandra, Kafka, any sort of application which requires the distributed nature and reduce risk of failures. Any question about the partition group? So here, how we can create the partition group is, what you need to do is, so first we need to create the placement group here. So here you can see there is a placement group, and you just need to give the name of your placement group and choose a strategy. So there is 3 strategy: cluster, spread, and partition. And you say, let's say I'm giving it this name, and let's say I'm selecting as partition. And here you can define the number of the partitions. So the maximum can be 7. And if you're selecting a spread, then the spread level is rack. Host is for the outpost only. So that is something very specific. So, or for the cluster, you do not need to do anything. You just create the group. And while launching your EC2 instance, you need to select the placement group. So you go to advanced detail, and here you need to select your placement group. So currently I have created this demo placement group and the strategy is cluster. So I can select this, and whatever instances will be part of this cluster placement group, they will be deployed on the same physical network to ensure the ultra low latency and high network bandwidth, because that's the cluster type of group. Clear? Any questions?
The price based the the placement group, the price differ? Like,
no, see, it is just the placement strategy. It has nothing to do with the pricing. Okay, so like in the end, if this is an on-demand instance, you will get priced on the on-demand. So basically, it does not affect the pricing. It is just the how your EC2 instances are getting placed. That's it.
okay. Awesome.
Okay. Okay. Now we have something called the Elastic Network Interface, or ENI, and these are basically the logical component in a VPC, and they represent a virtual network card. So they are what given EC2 instance access to the network. So basically, whatever we are discussing, this private IP, public IP, these are not directly assigned to your EC2. So this is, let's say, EC2. In your EC2, there will be ENI. Those public IP, private IP, elastic IP will be attached to this ENI, not to this EC2 basically. Okay, so they are the what gives EC2 instances access to the network, and but they are outside EC2 instance as well. So for example, we have an availability zone and we have one EC2 instance, and it is attached. You can see H0 primary, and it is attached to H0 your primary ENI, and this will provide your EC2 instance network connectivity. For example, a private IP. So each ENI can have the following attribute. Number one, it can have a primary private IP, one or more secondary IP. So in this example, I have one of 0, but you can have a secondary ENI also to the EC2, and that will be like H1 or something like that. So each ENI can also have an elastic IPv4 per private IPv4 or one or more public IPv4. So it gives you a private and public IP. We can have one or more security group attached to ENI, and you can also have a MAC address attached to it. And other things, like the most important bit is you can create ENI independently from your EC2 instances and attach them on the fly and move them from EC2 instances for failover. Okay, so and they are bounded. to a specific availability zone. So let's say if your ENI is in US East 1A availability zone and there is an instance in US East 1B availability zone, then you cannot attach that particular ENI to this instance. Instance and ENI both should be in the same availability zone. Okay.
One question.
Yeah.
Just,
Yeah,
so
sure.
one instance can have multiple ENI attached to them, right?
Yes, they can have. Yes.
Okay.
So in that case, see, right now, this is, let's say, your EC2 instance. Now, currently, we have assigned this H0, that is your network card, and it has a public IP and the private IP, 172.68.33.4, and it has something 10.2.3.4, something, right? So this is, let's say, private IP, and this is public IP. Now you can access whatever application running on it, either from the public internet using this and from the private network using this. Now what happens is you can attach another H1, and that way you can assign it to 192.68.40.5 or 10.3.5.7. So you can attach multiple network interface card to your EC2 instances. So if I go here and it will be in the BPC. EC2 only. This network interface. So you can see currently I have this one network interface ID which belong to this subnet and the BPC ID. It is bound to EU North 1B. Security group also attached to it, and it is attached to this instance ID, and the current status is in use. And you can see the public IPv4 and the private IPv4 are actually assigned to the ENI, not to the EC2, and ENI is attached to the your EC2 instance. So for example, if I detach it, okay, it's a primary, so we cannot detach it. So you can create another network interface card and attach it, and we can detach it. So the main thing you can see here, this is in EU North 1B, and if you go to your instance, and here if we see in which availability zone it is, so it will be in the EU North 1B only. Here is availability zone coming. Yeah, EU North 1B.
It should be on the same availability zone.
It should be on the same availability zone. So let's say if I create an network interface, let's try to do that. If I let's say in EU North 1A, okay, and I'm just creating the network interface, for example, keeping all the default option. Okay. Now, if I try to attach it, so you see no running instance is in the EU North 1A. But if I go, I'll delete this. But if I create a network interface in EU North 1B, and if I tried, which one was that? You can see here, it is available, right? So if I try to attach it to the instance, you can see now I'm getting an instance. So I can attach it.
Right.
Now my EC2 instance is two private IPs.
Right. So one more thing is like each resource we create, we should assign a specific VPC, right? Its resource cannot be outside of the VPC. Is that correct?
It is not true for all the resources. Okay. So there will be certain services that we will keep seeing. So for example, when you create S3 bucket, S3
Right.
bucket is independent of your VPC. It is not a part of VPC, but there will be multiple services which will be part of VPC. So the statement is not entirely correct. There will be some services which need to be part of any VPC. So for example, EC2 stack, right? So when you deploy an EC2, it must be a part of any of your VPC. So if we do not define any custom VPC, then it will go get placed inside the default VPC.
Correct. Is there any way we can differentiate, okay, which one should be, I mean, I know AWS can do that, okay, it doesn't need to be on that VPC, but is there any way we can distinguish, okay, this service, we don't need to put in a VPC or something like that?
No, so once you know all the service, you will get an idea like which services you need to put up in a VPC. So that is what I'm saying. So mostly the compute service, okay, they will be inside the VPC. So when you select a Lambda, when you're working on the Elastic Beanstalk, when you will be working with the containers, they mostly will be inside the VPC. But the storage services, data services, all the managed services generally will not be part of the VPC. They will be independent of the VPC.
All right, sounds good. Thanks.
Okay. So, but what we are going to see in the networking. So let's say, for example, I'll just give you a very basic glimpse. So let's say when we are saying this is your S3 bucket, for example. Now, this is your VPC. Now we say S3 bucket is independent of the VPC. But in the networking, we can configure our networking in such a way that this S3 bucket will get only connection from this VPC. So even though if it is not a part of VPC, if I try to access it even from another network, I will not be able to do this. So the life cycle of S3 will be independent of the VPC, but it will accept the connections only from a particular VPC. So all those type of customization, we can do that.
Okay, thanks.
Okay. Now we have something called as the Hibernate. Okay. So and it is a very lesser known feature, and people generally do not use this also. Like I have never used this. Okay. So this is a very lesser known feature. We called it as the EC2 Hibernate. So we know that we can stop and terminate our instances. And when we do so, when we stop it, the data on the disk, on your EVS disk, is going to be kept intact until the next restart. But if we terminate it, if we set up the root volume to be destroyed with our instances, it is going to be destroyed. But any volume that is not set up to be destroyed, when your instance is terminated, will be kept, right? So, and then when we start our instance, the operating system will boot, and then the EC2 user data that was going to be run, the script, then the operating system will boot, and then your application starts. So your cache get warmed, and that can take some time because we are booting our machine. But the idea is that with Hibernate, we want to achieve a new state. When we hibernate an instance, whatever was in RAM, the in-memory state is going to be preserved. Okay. So what does this means is your instances is going to boot up faster. Boot time is going to be much faster because the operating system is not stopped or restarted. The operating system is actually just frozen. It's hibernated. And under the hood, well, whatever was in the RAM state is going to be written into a file in the root EVS volume. So that means the root EVS volume must be encrypted, and that it must have enough space to contain in the RAM. So we take an EC2 instance and it is running and there is the data in RAM. So then we start a hibernation process. So what happens that the instance will go into the stopping state and the RAM is going to dump into your EVS volume. Then the instance is shut down and the RAM disappears. Because as soon as you stop, an instance of the RAM goes away, right? But the EVS volume still contains the dump of the RAM. So when your instance is started, the RAM is going to be loaded from the disk onto the EC2 instance memory. And that means that your EC2 instance never got stopped. Okay, so the use case for the hibernation is that if you have a long running process and never actually stop them, or if you want to save the RAM stack, or if you just want to reboot, like boot up fast, and you have services that takes time to initialize, you may want to stay up and running even if you hibernate your instance. So the good thing to know about hibernation is that it support a lot of different instance families. The instance RAM size must be less than 150 gigabytes. So if your RAM is less than 150 GB, then you cannot hibernate your instance. Now that can change again, and you are not going to test on these numbers, so we do not need to worry about it. Instance size, and again, it does not work on the bare metal instances. It works for many operating systems, including the Linux and Windows. It works only for the root volume, and the root volume must be an EBS volume, and it must be encrypted as well. It is available, and it must be large to contain the RAM, and that you dump onto it. It's available for all kind of instances such as on-demand, reserved, and the spot instances. And hibernation is meant to be no more than 60 days, and this can change. So hibernation is basically whatever you are going to store in your RAM, it is going to store, for example, in your what we can say, in your EVS volume, and when you when you hibernate it, it is going to be placed in this machine, right? So we can do, I can give you a small glimpse of the hibernation, but since we do not have a running application, so let's say, for example, we have this instance. So I'll go to EC2 instance. Okay, it is running. So I'll connect to this. Okay, and if you put up the uptime, so it is up from last 28 minutes, right? So if we stop this server, basically if we hibernate this server, then let's see what happens. So currently, if you go and try to hibernate, this will not be enabled, right? So what we need to do is we need to instance setting, change the shutdown behavior. Hibernate behavior we will not be getting while once the user is created. So we can change the shutdown behavior, but we are not getting the hibernation behavior. So let me create another instance. That is okay. Hibernate demo and one number of the instance, and the most important thing here is enable. Okay. And if you see, to enable the hibernation, space is allocated on the root volume to store the instance memory. Make sure the root volume is large enough to store the RAM content and accommodate your expected use. Okay. And I will launch this instance. Okay, edit the instance config. Where is my root volume? Go to advanced. So you can see the encryption, I need to enable it. Okay, I'll launch the instance. So I'll connect to this instance. Okay, I will wait for a minute here till the time it is more than 1 or 2 minutes. So now you can see the instance is up from last 1 minute. I'll just wait for a minute also. Once I'll get 2 minutes, then we will go back to the console. Okay, now it is up 2 minutes, right? Now what I'll do is I'll go to instance, and in the instance state, you can hibernate the instance. If you hibernate the instance, to confirm that you want to hibernate the instance, choose the hibernate button below. So hibernation means basically it is now you cannot connect to it, right? The system will hibernate now, and basically it is stopped. So if you go to instance and you see this is stopping.
But are you gonna get charged for that? Like even if it's hibernating?
No. See, I will tell you regarding that. Just give me a second. So you are not going to specifically charge for this, but when you configure your EC2 instance, everything. So let's say I select an hibernation on. So the price will include in your on-demand EC2 instance only.
Okay. And
Okay.
probably the EPS volume I'm using for
Yeah.
that
So
one too.
we will cover EVS volume separately. Okay. Yeah, EVS volume, like whatever the data that you will be storing, you will be charged definitely for that.
Hmm.
Okay. Now it is stopped. Now, when I'll start this, you will see now it is running. I'll just go and connect it to this. even though we have started the server just seconds back, you see what we are going to get in the uptime. You can see it is up from last 3 minutes, as if the server never got shut down, right? So that is the purpose of the hibernation, where your whatever data there is in the RAM will boot up pretty fast. So as if you are saving the state of your EC2 instance, and it looks like that your server never went down at all. So boot up process will be really faster. So that is the whole purpose of the hibernation. Okay, so next we will cover the instance storage, and we will cover this in tomorrow's class. Any question for whatever we covered today?
No, thank you.
Yeah, this will be it from my end today. Thank you.
Thank you.
Thanks. Bye.
Good night.
Right.
Thank you.
Thank you, Rocha.
Thank you, Albert. Thank you, Raj.